Assalamu alaikum warahmatullah, Dr. Roseli. Today we're going to present thermal application and focus on the critical analysis and design of the EV cars battery. So I am Abdurrahman Khan and my team Aminina and Etienne. So let's start with introductions. The Paris Agreement has drawn together 95 countries around the world with the common goal of reducing the greenhouse gas emission and gradually transitions to the carbon-free society. As a result, much effort is being put into increasing the proportions of renewables energy in the total energy generated in the regions. However, all the renewable energy resources are affected by the problem in intermittency. Also, electric vehicles currently make up the barely 0.1% of the worldwide high-duty vehicles fields, making large-scale electrification of the road transportation industry difficult. The fundamental difficulty is electrical vehicles are currently twice as expensive as their internal combustion engines. Converters up 46% of this cost is accounted by the electrical vehicles battery packs. For the next 5 to 7 years, it is expected that battery pack will be continuous to be the determining factors of the expensive of the electrical drivetrain architecture. So the problem statement. Okay, the reliability is one of the charge for the lithium battery. This is because the lithium-ion battery is prone failure due to the reasons of the mechanical vibration, exposures to high impact force and thermal problem. Lithium batteries have long been used in the single cells format for small portable electrical devices. Also, the performance of the LV is high relative to the temperature, which play major role in the battery performance. Battery temperature has a strong influence on the speed of the charge and discharge the battery. Also, due to the high demand of the electrical vehicles in the future, battery is one of the main part of the electrical vehicles technology. Current electrical vehicles use lithium battery, which are expected to be the main power source of this LV. Also, because the diminishing share the battery market that depend of the electrifications of the vehicles and their end-use expectations have been the primary drivers of the development of the advanced battery technology over the past decades. The objective. So the objective of this report are to design a lithium battery-based energy storage system and to define the cooling system that can be increase the battery lifespan. Also to define the best performance of the lithium battery with the response cost. So next class, Manina is going to present it.
Okay, thank you very much. So we proceed with the critical literature review. Okay, battery management system, which is BMS, can be referred to a management scheme that monitor, control, and optimize the performance of an individual or multiple battery module in an energy storage system. So basically, the BMS can be functioned as a monitoring, protection, charging and discharging, communication, diagnosis, and data management. So that proceed with the battery pack design. So here there are 3 types of battery, which is a cylindrical cell, prismatic cell, and pulse cell. So for the cylindrical cell, it has a clump cell battery design, which is have a greater energy storage, high ductility, and processability. And then for the prismatic cell, commonly utilized for a bus bar holder. And then lastly, for a pulse cell, easily to fit into a compact location, mineral filled product, and also have a good ductility, flame retardant performance. And then for the EV battery system, it have a 6 system interface, which is mechanical, structure, thermal, electrical, control, and support. So for this report, we more focus on the mechanical and also for the thermal. And then for the air cooling, so in a consumer electronic business, air cooling is a commonly employed. So according to the Routledge 2005, conventional air cooling technique for the electronic thermal management include the heat sink with the convective and radiative heat transfer structure, thermally conductive material development, heat pipe structure, airflow optimization, and temperature monitoring. So this fundamental of active air cooling, BTMS, the active for the bottom pictures, it contains the battery pack, cooling channel, inlet and outlet, as well as a cooling fans. Okay, next for the cooling channel design. So to achieve the best thermal performance with the lowest cost, the more specific energy, the optimal cell size for the specific battery pack should be addressed in the design phase. So to achieve the optimum battery pack design with a combination of a small pack volume, low temperature difference and low temperature standard deviation. So there are three type of the channel design that we need to consider, which is Z type, U type, and also J type. And then for the structure of the lithium ion, so the battery is basically having a lot of electrochemical cells that connected in series in parallel to provide a voltage and capacity. So each cell contains a positive, which is cathode, and negative, which is anode. So the most commonly used for the anode is a graphite, and then most commonly used for the cathode is a lithium iron phosphate. And then proceed with the methodology. So for the first one, for the mechanical design. So for the mechanical design, we consider to have a 3-pack of a cylindrical battery. And then so across member are used to divide among the battery pack into numerous compartments where 3 packs have been done. So the central battery pack member can be separated into left and right compartment, as you can see in the pictures. And then proceed with the cooling system. So for the cooling system, here have our design, which is the cooling system consists of the aluminum plate and also the ethylene glycol. So here the combination between the air and liquid cooling. So thin square aluminum plate as a cooling plate. So mixture of the ethylene glycol and water as a liquid cooling. So the battery will be then placed inside the air cooling system, and then the coolant enter the channel from one side of the plate and flow through it before existing from the others. So it will be sandwiched between the two battery cells in operation, with each cell producing heat that is transferred to the plate, and finally it can be a coolant. I think that's all from me. Thank you. Then I will proceed with then we'll pass to the intern.
Thank you, Amalina. Next, we move on to discussion, where first will be the discussion on the battery pack, where it is designed based on the consideration of many subsystems, which are the communication between interfaces on mechanical, structural, thermal, electrical, control, and support, which all of this will affect the safety and also reliability of the battery pack. So on the other hand, the design of the battery cells also plays a crucial role, where the structural design of the battery cells have been chosen is the cylindrical cell, where it have more consistent of automation in which can withstand high internal pressure. So next would be regarding the air cooling. The advantages of air cooling are direct access, low in viscosity, and also lightweight of air. So on the other hand, it is also low in cost and easy maintenance. However, based on the present study, the system of air cooling are used by PTMS, where it is improved by using a plate of aluminium and liquid cooling with water. This is in order to enhance the performance and also reduce the heat transfer of the battery. Okay, next we move on to the future development of the material, in which in this study, LIBs have been proven to be most robust tech in the development of EV. So on the other hand, based on the aspect of the material, LIBs have been the most suitable on improving aspects such as specific energy and power. So next should be regarding the cathodes, as its new material is made of completely cobalt-free composition, where its composition of high nickel NMC material has its advantage of reducing costs, increase on its capacity, and also reducing the risk in cobalt supply. So lastly will be the conclusion, whereas the performance of the battery can be enhanced by using cathode of high nickel, in which will mainly reduce on the cost, increase capacity, and reduce the risk. Okay, next will be the design of the battery, where the cylindrical type is used due to its safetiness and also cost. And lastly would be the air cooling, where ethylene glycol and water will be expected to reduce even more heat transfer to the cell battery, as the plates of aluminium will absorb the heat from the cells. That's all from us. Thank you.